We're going to do a little bit more work on linear approximation and do problems more focused on AP type problems. Now, the main idea again with linear approximation is that for any curve, we can approximate points on the green line using a tangent line at that point. And the closer we are to the point of tangency at that initial point x naught, f of x naught, as long as it's close to that point, that red line approximates the green curve. And again, that's because as we zoom in, when we get closer and closer, any curved line is going to look straight. So to do linear approximation then, we need a tangent line equation. And for the tangent line equation, we need the point slope form. So in this case, the f prime x naught, I'm just going to highlight this part here. This part represents the slope, and then we have x naught, f of x naught represents the x and y coordinate. So we need the slope and the point to do this. So looking at example 1, you're given a function, 1 over 4 x squared minus sine x. We're going to use a tangent line at x equals 0 to approximate the values of f of 0.5. Okay, so that's a point that's relatively close to 0. So the first thing I'm going to do is I want to find the slope, so I need a derivative. So I'm going to differentiate this. So f prime of x is equal to, differentiating the x squared, I get 2 over 4x. So I'm going to simplify that to x over 2 minus the derivative of sine is cosine of x. Okay, so I want to find the slope, so I'm going to take the derivative value at x equals 0. So I'm going to plug 0 into that equation, and then I'm going to calculate my slope. In this case, I'm going to end up with 0 minus cosine of 0 is 1. So then my slope, my f prime value at 0 is equal to negative 1. So I have the slope for my point slope form. I need to find the y coordinate of where that point is tangent. So I'm going to plug it into the original equation. So I need a y coordinate, so it's going to be f of 0 is going to give me the y coordinate at 0. So f of 0 is equal to 0 minus sine, so it's going to be 1 over 4, 0 squared, so that's 0, and sine of 0 is equal to 0. So I have f of 0 is equal to 0. Okay, so then the y coordinate at x is 0, I'm just going to put up here y is equal to 0 as well. So the equation of my tangent line, is going to be y equals negative 1 being my slope, x minus, well, that's going to be 0, plus 0. Okay, so that equation simplifies to y equals negative x. So that is the equation of my tangent line. So I'm going to use this line then to approximate f of 0.5. So we're going to say that f at 0.5 is going to be approximated by the y value at 0.5, and that's going to be equal to negative 0.5. Okay, so that is my approximation. That is the approximate value at 0.5. Okay, so that's going to be part 2. Part 3 says use the second derivative to determine the linear approximation is an over or underestimate. So we are going to use the concavity. So if something is concave up, we know that the linear approximation is going to be an underestimate. Sketching that in. So my linear approximation is an underestimate. If something is concave down, we know that the linear approximation will be an overestimate. Okay, so calculating the second derivative then, so we're going to say that f double prime at x is equal to 1/2. So I'm going to differentiate that original f prime, x over 2 minus cos x. So 1/2, the derivative of cos is negative sine, so it's going to be plus sine x. Okay, and I could use this to check the concavity. So the second derivative at x is 0. When I plug in 0, I'm going to end up with 1/2 plus 0. So this is going to be positive, meaning that we have positive concavity. Therefore, concave up, so this is an underestimate. So y, the linear approximation y, is an underestimate. Again, we can see if we just sketch our line in, it is below the curve.